Welcome to Night Watch Observer. It's lovely to have you here wherever you are tonight. Maybe you're under a heavy blanket with the lamp still on, the kind of light that's just warm enough to keep the room from going fully dark. Maybe you're on a train or a couch or lying flat in the quiet with your eyes already half closed. Wherever you are, settle in. There's nothing you need to do for the next little while except breathe slowly and let the words drift past you like something far away. And before we begin, just a small, soft thing. If you find these slow nights helpful, a like and a subscribe really does help this quiet little channel keep going. Small creators like me rely on it more than you'd think. And to those of you who already subscribed, who come back night after night, thank you. Truly, it means a great deal. While you're settling, I'd love to know in the morning, if you remember, where in the world are you listening from tonight? And what time is it in your corner of the dark? Leave it in a comment. It's nice to imagine all of you out there, scattered across the night side of the planet, all listening to the same quiet voice. And here's the thing I should say up front. I'll try not to make this so interesting that it keeps you awake, but if it does, well, at least you'll have learned something, a fair trade. And if you drift off long before the end, that's perfectly fine. The facts will still be here. The little object we're going to talk about tonight has been patient for almost 50 years already, and it'll be patient for billions more. It can wait for you. So, let's begin, shall we? Let's start, of all places, far out past everything you've ever touched. Right now, while you lie there is a small metal disc moving away from you at about 17 kilometers a second. Not 17 kilometers an hour, the way a car moves, 17 kilometers every single second. In the time it took me to say that sentence, it traveled the length of a small country. It does not slow down, it does not stop to rest. There is nothing out there to slow it, no air to drag against it, no road to end. It simply keeps going, and it has been keeping going since before many of you were born, and it will keep going long, long after. And here is the strange and lovely part. That little disc is a record, an actual phonograph record, the kind your grandparents might have set a needle onto. Gold, round, about the size of a dinner plate, bolted to the side of a spacecraft, sailing out of our solar system and into the dark between the stars. We made it on purpose. We sent it out deliberately. And tonight, very slowly, with no rush at all, we're going to walk all the way around it. One quiet fact at a time. What it's made of. What's etched onto its cover. The pictures hidden inside it as sound. The hellos in dozens of languages. The whale song. The music. And one secret, tender thing buried in it that almost no one ever mentions, which we'll come to much later, when you may already be asleep. So let's hold the object itself first. Let's just look at it the way you'd look at a single thing in a dark, empty museum with all the time in the world. It's called the Voyager Golden Record, and the first thing to understand is that it's a real physical disc, 12 inches across, the same size as the big vinyl records people once stacked beside their turntables, but it isn't vinyl, it's made of copper. Copper, that familiar reddish metal, the same metal inside the wires in your walls, the same metal in an old penny, a round plate of copper, and then over that copper, a thin, even layer of gold. Gold-plated copper. Say it slowly and it almost sounds like something from a fairy tale, and in a way it is. The gold isn't there to be beautiful, though it is beautiful. The gold is there to protect, because copper, left bare in the rough world, tarnishes and corrodes and slowly turns dull. But gold doesn't. Gold is one of the most stable metals there is. It barely reacts with anything. It doesn't rust, it doesn't tarnish, it just stays. And so they wrapped the copper in that thin golden skin, the way you might wrap something precious in a soft cloth before putting it away for a very long time. The gold is the cloth. It guards the copper underneath against the slow damage of space, against the tiny specks of dust and grit out there that, even when they're smaller than a grain of sand, can pit and scar a surface when you're traveling fast enough to meet them. And that is the quiet astonishment of this object. It wasn't built to last a year or 10 years or a human lifetime. The people who made it estimated that this gold-covered disk could remain readable for something like 1 billion years. 1 billion. Try gently to hold that number, though you don't need to grasp it fully. Think of it this way: the whole of recorded human history, every pharaoh, every empire, every song ever written down, fits inside a few thousand years. This record was made to survive for a span hundreds of thousands of times longer than all of that. Out there in the vacuum, with no air to weather it, no water to dissolve it, no rain, no wind, no hands to wear it down, the gold surface should simply remain, quietly intact, long after the planet that made it has changed beyond all recognition. And there isn't just one of these disks, there are two identical copies made as twins. One was mounted on a spacecraft called Voyager 1, the other was mounted on its sister ship, Voyager 2, and both of those spacecraft launched in the same year, 1977. Now here's a small thing that's always felt gently wrong, in a way that makes you smile once you understand it. Voyager 2 launched first, Voyager 1 launched second, the numbers are backwards. Voyager 2 lifted off on the 20th of August, 1977. Voyager 1 lifted off a couple of weeks later, on the 5th of September. So why is the one that left first called number 2? Because of the path each one took. Voyager 1, the second to launch, was sent on a faster, more direct trajectory. And so even though it left the launch pad later, it pulled ahead. It caught up to its twin out in the dark and then passed it, the way a faster runner who starts a little behind can still cross the finish line first. The second twin overtook the first, and so the names came to match the order they'd reached the outer planets, not the order they left the ground. It's the kind of small, human, slightly confusing detail that makes the whole thing feel real. Not a perfect myth, a real project made by real people with real reasons that don't always line up neatly. So picture them now. 2 spacecraft launched within a few weeks of each other almost 50 years ago, each carrying an identical golden disk, both of them traveling away from us in different directions, both still going. Twin messages sent in 2 directions at once, so that if one is lost, the other might still be found. And the disk itself doesn't travel naked and exposed, it's tucked inside a protective jacket made of aluminum. Think of the jacket like the sleeve a record used to slide into, the cardboard cover that kept the disc safe and clean on a shelf. Except this jacket is aluminum, and it's doing far more than keeping out dust. It's the first line of defense for the gold disc inside, and it's also the page where the instructions are written. Because here's a problem the people who built this had to solve, and it's a strange and beautiful problem to sit with as you're drifting off. Imagine you make a record, a message, and you want someone to be able to play it, anyone. But you have absolutely no idea who that someone might be. You don't know what they look like, whether they have hands, whether they have eyes, whether they think the way you do at all. You don't know their language, because they have no language you've ever heard. You don't even know if they exist, and whoever they are, if they ever find this disc, it will likely be so far in the future that we, all of us, everyone alive tonight, will be long gone, and the Earth itself may be unrecognizable. How do you leave instructions for a stranger you cannot picture, who lives in a time you cannot imagine, who shares not one single word with you? That's the puzzle. And the answers they came up with are, to me, the most soothing part of this whole story, because the answers are patient. They assume almost nothing. They start from the very, very beginning. The first answer is simply this. They gave the finder the tool. Mounted right there alongside the record is a phonograph cartridge and a stylus. The stylus is the needle, the tiny pointed thing that rides in the groove of a record and reads the bumps and wiggles as sound. The cartridge is the little housing that holds it and turns its movement into a signal. So whoever finds this disc isn't just handed a mysterious golden plate and left to puzzle over it forever. They're handed the very instrument they'd need to play it, sitting right there beside it. It's as if you buried a letter for someone 1,000 years from now, and you buried, alongside it, a pair of glasses in case they couldn't read small print. You give them not only the message, but the means. But a needle alone isn't enough, is it? You'd still need to know what to do with it, how fast to spin the disc, where to start, which way is which. And so the second answer is etched in lines and symbols right onto the surface of that aluminum cover. Drawings. A kind of diagram scratched into the metal that tries to explain without a single word exactly how to play the record and how to turn it into pictures. And this is where it gets genuinely clever in the gentlest possible way. Because how do you draw the instruction, spin this disc once every 3.5 seconds for someone who has never heard of a second? Think about that for a moment, slowly. A second isn't a fact of the universe, it's a human invention. We made it up. It comes from dividing a day into hours and an hour into minutes and a minute into seconds. All of it tied to the spin of our particular planet around our particular star. A being on the other side of the galaxy would have no reason to know what a second is. Their day, if they even have days, would be a completely different length. So if you wrote 3.5 seconds on the cover, it would mean nothing. It would be like writing directions in a language no one else has ever spoken. So the people who built this record needed a different kind of clock. A clock that isn't human at all. A clock that anyone, anywhere in the universe, could rebuild from scratch using nothing but the laws of nature, which are the same everywhere. And they found one. They found it in the simplest, most common thing in existence: hydrogen. Hydrogen is the most abundant element in the whole universe. It's the lightest, the simplest atom there is, just one proton and one electron, a single particle with a single partner. Stars are made mostly of it. It's everywhere, in unimaginable quantities, scattered across every corner of space. Any civilization advanced enough to catch a spacecraft drifting between the stars would certainly know hydrogen. It would be one of the very first things they understood about the cosmos. And hydrogen does something quiet and regular, something that ticks like the smallest possible clock. Let me try to explain it the way you'd explain it to a friend half asleep with no need to follow every step. Inside that single hydrogen atom, you have the proton in the middle and the electron around it. And both of those tiny particles spin in a sense, each one behaving like a minuscule magnet. Now those two little magnets can be lined up two ways. They can point in the same direction or in opposite directions, and every so often the atom flips from one of these arrangements to the other. When it does, it releases a tiny, precise pulse of energy, a little radio whisper, and that flip happens with extraordinary dependable regularity. It is, in effect, the ticking of a natural clock built into the most common atom in the universe. This particular flip even has a name, the hyperfine transition, but you don't need the name, you just need the picture. A simple atom, flipping, ticking the same way everywhere, for all time. And that tick is fast, astonishingly fast. The whisper of energy it gives off vibrates about 1,420 million times every second, near 1420 megahertz if you want the number. But the number isn't the point is the rhythm. A single tick of this hydrogen clock lasts only about 7/10 of 1 billionth of a second, an almost unimaginably tiny slice of time, far too small to feel, far too small to see, but perfectly steady, perfectly reproducible, and gloriously universal. So here's the elegant trick. On the cover of the record, they drew the the hydrogen atom. They drew it in its two states, the two ways those little magnets can line up, the before and the after of that tiny flip. And by drawing it, they were saying, in effect, here is our unit, here is the one, this is the tick we will count by. You know this atom. You can rebuild this clock yourself, and once you have it, everything else on this cover is just a number of these ticks. And so when the cover needs to say, spin the record once every 3.5 seconds, it doesn't say 3.5 seconds. It says it as a number of hydrogen ticks. An enormous number, of course, because each tick is so tiny, but a number that any being who understands hydrogen could read and reproduce exactly. They could build the clock from the atom, count out the ticks, and arrive at precisely the right speed without ever knowing what a second is, without ever having heard of Earth, without sharing a single word with us. Just over 3.5 seconds for one full turn of the disc. That's the speed. In the old human language of record players, you could also call it 16 2/3 revolutions per minute, a slow, unhurried spin, slower than the records people usually played at home. A gentle rotation, a little more than 3.5 seconds, to come all the way around again and again and again. There's something fitting in that, isn't there? That a record meant to be patient for 1 billion years should also turn so slowly. No rush. Just a slow, steady circle. And once you understand that one idea, the hydrogen atom as the universal one, the rest of the cover unlocks. Because every other measurement on it, every distance, every duration is written in the same way as a count of those same ticks. The whole diagram rests on that single foundation. Define the one and everything else follows. It's the same instinct you'd use if you were trying to leave a message for someone with no shared language at all. You'd start with something you were certain they'd recognize. You'd point at the simplest, truest thing you both could see, and you'd say, this. Start here. Build from this. And that's what they did. They reached for the most common atom in the universe and made it the heartbeat of the whole instruction. A clock anyone could rebuild. A one that means the same everywhere there is. Let that settle for a moment. A golden disk smaller than the span of your two hands, spinning slowly in the dark, its speed written not in human time, but in the ticking of hydrogen itself. The same hydrogen that fills the stars. The same hydrogen, in fact, that's inside you, in every drop of water in your body, in the air, just above your blanket. The clock that times the record is the same clock ticking quietly inside everything, everywhere, including the warm, breathing room you're lying in right now. There's a kind of comfort in that, I think. The makers of this record could not have known who would find it, or when, or whether anyone ever would. They couldn't leave a phone number or a return address. They couldn't leave a language. So they reached past all of that down to the things that don't change. The simplest atom, the steadiest tick, the most common element there is. And they built their message on that foundation, trusting that whatever else might be uncertain, hydrogen would still be hydrogen 1 billion years from now on the far side of the galaxy, ticking exactly as it ticks here in this room tonight. So that's the body of the thing, the disk itself, and how to play it. Two golden twins, gold over copper, made to last 1 billion years, launched in 1977, one quietly overtaking the other in the dark, tucked in their aluminum jackets with a needle and cartridge bundled alongside, and a cover etched with patient symbols, all resting on the single, universal heartbeat of the hydrogen atom. But we've only looked at the outside so far. We've learned how to play it, not what's on it. We've held the cover in our hands and read its first careful instruction, the speed of the slow turn. And right beside that instruction, etched into the very same cover, are two more things. Two clocks of a very different kind. Not clocks that tell you how fast to spin the disc, but clocks that tell you something far stranger and more beautiful. Clocks that tell you when this record was made, and from where, in all the vastness of the galaxy, it came. Because the people who built this thought of something quietly profound. They realized that whoever finds this record will find it adrift in time as much as in space. It might be 10,000 years from now, it might be 1,000,000, it might be far longer, and a finder holding this golden disc might naturally wonder, how old is this? When did the hands that made it do their work? And from which faint point of light among all the countless stars did it set out? And so, on that same etched cover, they left a way to answer both questions, a way to read the date and a way to read the place. 2 more diagrams, 2 more quiet pieces of cleverness, waiting there in the metal. One of them uses a tiny speck of a special element, glued right onto the cover, slowly counting down across billions of years. And the other is a map drawn not with roads or coastlines, but with the rhythms of distant spinning stars, 14 of them, arranged around a single point that marks our sun, our home, the small warm star you orbit, the one you turned away from when you closed the curtains tonight. We'll come to both of those, slowly, in just a little while. The little buried clock that ticks down over 4.5 billion years, and the map of spinning stars that whispers, to anyone who can read it, here is where they were. But for now, just rest with what we've gathered. The disk, the gold, the twins, the slow turn timed by the heartbeat of hydrogen. Let it sit in the dark behind your eyes like a small golden circle, turning once every 3.5 seconds, somewhere very far away where it's quiet and cold and perfectly still, except for that slow, patient spin. You don't have to remember any of it. The facts will keep. The record has been patient for almost 50 years, and it can be patient a while longer while you drift and breathe and let the dark settle softly around you. There's no rush at all. There never was. Let me come back for a moment to the object itself, the thing that is actually out there, hurtling through the dark while you lie still. Picture a disc about 12 inches across, the size of an old vinyl record, the kind your grandparents might have slid out of a paper sleeve on a Sunday afternoon. But this one isn't black. This one is copper, and over that copper, a thin breath of gold. Just enough gold to wrap the metal in a skin that won't tarnish, won't pit, won't slowly eat itself away in the way that bare copper would. Gold is patient like that. It doesn't react with much. It doesn't rust. Out there, where there's no air and no rain and almost nothing at all to touch it, that gold layer is expected to keep the copper safe for something close to 1 billion years. 1 billion. Say the word slowly and it stops meaning anything. It's longer than there have been flowers on the earth. Longer than the continents have held their present shapes. And the gold is there mostly to guard against 2 small enemies: corrosion, the slow chemical wearing away, and the occasional sting of a micrometeorite, a grain of cosmic dust moving fast enough to scratch. Against those, a whisper of gold, holding the line for an age. There are 2 of these disks, identical twins, one bolted to the side of Voyager 1, one bolted to the side of Voyager 2, and they left home in the same season, the late summer of 1977. Voyager 2 went first on the 20th of August. Voyager 1 followed it about 2 weeks later on the 5th of September, which sounds backwards, doesn't it? The one called 2 leaving before the one called 1. But they were put on different paths, and Voyager 1 took the faster road, the shorter arc, and it caught its twin, and passed it out there in the silence, and never looked back. So the second to leave became the first to lead, both of them carrying the same golden circle, the same songs, the same 55 hellos, the same one woman's quiet brainwaves, which we'll come to later when you're sleepier still. Each disc doesn't just travel naked either. Each one rides inside a jacket of aluminum, a protective sleeve, and tucked in with it, bundled alongside, are the very tools you'd need to play it: a phonograph cartridge and a stylus, a needle. Think of that for a moment. They didn't just send the record, they sent the player. or at least the heart of it, the small piece that reads the groove, as if to say, we know you might not have anything like this where you are. We know our way of making sound might be strange to you, so here, take the needle too, here's how to listen. And that's where it becomes almost tender, the thought that went into this. Because how do you write instructions for someone you will never meet? Someone who may not share a single word, a single number, a single idea with you? You can't write them down. Not in any language. So the people who built this didn't use words at all. They used pictures. Diagrams etched right into the surface of that aluminum cover, scratched into the metal in clean, simple lines, meant to be understood by anyone, anywhere, who looks closely and thinks carefully. And one of the very first things those diagrams have to explain is the simplest and somehow the hardest thing of all: how fast to spin it. Because a record only makes sense at the right speed, too slow, and the music sags into a low groan, too fast, and it chitters away into nonsense. You have to turn it at just the right pace, and on Earth we'd simply say, turn it at 16 2/3 rotations every minute, one full turn taking about 3.5 seconds, 3.6 seconds to be a little more exact. That's the pace, that's the slow, patient spin you've been holding behind your eyes. But here's the trouble. You can't say a second to someone on another world. A second is one of our inventions. It comes from how we once carved up the spin of our own planet, the length of our own day, and there's no reason at all that a stranger out among the stars would have ever heard of it. A second means nothing out there. It's a local custom, a habit of one small blue world. So how do you tell a stranger how long 3.5 seconds is without using seconds at all? You reach for something that everyone, everywhere, must share. And there's really only one thing you can count on: hydrogen. The simplest atom there is, one proton, one electron, the most common substance in the entire universe. Wherever this disk drifts, whoever finds it, they will know hydrogen, they will have studied it. It is the same here as it is on the far side of the galaxy. And hydrogen does a very particular, very faithful little thing. Deep inside the atom, the electron and the proton can flip the way they line up, a tiny shift, a subtle change of state. And when they do, the atom gives off a faint, precise signal. Always the same signal, always at the same rhythm. That rhythm is unbelievably quick. The whole little event repeats in about 7/10 of a billionth of a second, a frequency near 1,420 million cycles every second, though of course you wouldn't say it that way to the stranger. You'd just say, count the ticks of hydrogen, this is your unit, this is the one heartbeat we both know. And so on the cover they drew it. They drew the hydrogen atom in its two lowest states, the before and the after of that little flip, the two arrangements side by side. And from that single picture they defined the number 1, the most basic mark on the whole diagram, the starting point of every measurement that follows. Here they're saying is 1. One tick of the most ordinary atom in creation. Now with that as your ruler, everything else becomes readable. Because once a stranger understands that one tick, the rest unfolds. The instructions can say, in clean binary marks, that one rotation of the disk should take a certain enormous number of those tiny hydrogen ticks, an almost unthinkable number of them, all crowding into a single, slow turn of the record because each tick is so fleeting and the turn is so long by comparison. But the math holds. You count the ticks, you do the arithmetic, and out comes the answer. 3.5 seconds per rotation, 16 2/3 turns a minute. The right speed, written in a language older than language, in the steady pulse of the most common atom in the sky. It's such a strange and lovely solution when you sit with it. We couldn't hand them a clock, so we handed them the one clock the whole universe carries inside its smallest, plainest parts. The clock that ticks the same in a distant nebula as it does in the air of your room right now, in the hydrogen of the water you drank, in the hydrogen woven through your own body, the same faithful little flip, ticking everywhere, in everything, always at the same pace. And on that golden disk, it became a way to say simply, "Turn me this slowly, listen at this speed, and you will hear us." So picture it once more, settling now, the aluminum jacket, the needle and the cartridge tucked inside, the gift of the means to listen. The cover etched with its quiet diagrams. The little drawn atom, flipping, defining the one, and from that one, the long patient count that sets the disk turning at 3.5 seconds a revolution. Once around, then once around again, somewhere out in the cold dark where nothing else moves. You don't need to hold the numbers, let them go soft. The 1420, the 16 2/3, the 7/10 of a billionth of a second. They'll be there when you wake, just as they've been there the whole time, written in metal, drifting outward. All you have to do right now is breathe and let the little golden circle keep its slow time in the dark behind your eyes, turning and turning while we drift on toward that buried speck of a clock and the map drawn from spinning stars in just a little while. And there are 2 clocks on the cover of that golden jacket. 2 separate ways to tell time, built into the same small piece of metal, waiting for whoever comes. The first one is a map. It's a diagram that looks, at first glance, like a child's drawing of a starburst. A series of lines radiating outward from a central point, each one a different length, each one marked with a tiny pattern of ones and zeros. 14 lines in all, 14 beams spreading out from a common center, each one pointing in a different direction, each one carrying its own quiet set of numbers. And at the end of one of those lines, shorter than several of the others, there is a small symbol, a mark. This one, this line with these particular numbers, points here, points home. That central point is our sun, and those 14 beams are pulsars. You may have encountered pulsars before, in passing. The name is evocative enough that it tends to linger. A pulsar is what you get when a massive star runs out of fuel and collapses, the core crushing inward under its own weight until the protons and electrons are forced together into neutrons, and what's left is a ball of solid neutron matter roughly the size of a small city, maybe 20 or 30 kilometers across, spinning at extraordinary speed. The collapse preserves the star's rotation the way a spinning ice skater does when she pulls in her arms. The original rotation, spread over an enormous star, collapses to a point and spins faster and faster until some of these objects rotate hundreds of times every second, and as they spin they emit beams of radio waves from their magnetic poles, beams that sweep around like a lighthouse as the star rotates. If Earth happens to lie in the path of one of those beams, we receive a pulse of radio energy with every rotation, regular as a metronome, often more regular than most clocks we'd built at the time. Each pulsar has its own unique rotation rate, its own private rhythm, distinct from every other pulsar in the galaxy. This is what makes them useful for a map. The committee, with astronomer Frank Drake centrally involved in the technical design, had used this same kind of map on the earlier Pioneer plaques, the ones carried by Pioneer 10 and Pioneer 11, spacecraft launched a few years before the Voyagers. The idea was elegant. Pulsars are named and identifiable, and their exact spin rates are precisely known. If you draw a line pointing toward each of 14 pulsars from a common center, and you encode each line's length proportionally to represent that pulsar's distance from the center, and you mark on the line the pulsar's rotation rate in binary notation, then you have built a kind of galactic address. A finder anywhere in the Milky Way could, in theory, identify the pulsars, triangulate the lines, and find the intersection. And there would be our star. Each line, then, is a beacon. Each set of markings is a unique identifier, the pulsar's own rhythm translated into ones and zeros. 14 lighthouses, each pulsing at its own speed, each located in a known direction from our Sun, the 14 together forming a cage of intersecting rays whose only solution is the single point where our star sits, roughly where the map says it does. And here is the thing that makes the pulsar map not just a map, but a time stamp. Pulsars slow down very gradually over immense spans of time. These spinning neutron stars lose energy. The rate at which they slow is in many cases measurable and predictable. So if you know what rate a pulsar was spinning when the map was made, and you know how fast it's slowing, you can calculate, working backwards from the rate you measure when you find the disk, approximately how long ago those numbers were written. The pulsar map carries its own decay built into it. The 14 pulsars, simply by spinning a little slower than they did in 1977, tell a finder when the record was made. Not precisely, but within a range. It's a clock made of slowing stars. The Pioneer plaques carried the same 14 pulsar map. The committee decided to keep that map consistent, to carry it forward, so that any finder of a Pioneer plaque and any finder of a Voyager record would have the same navigational system, the same style of coordinate grid, the same logical key. If any civilization in the galaxy ever finds one of these objects, they will find 4 of them, and all 4 will point home in the same way. Take a moment with that. 4 spacecraft now drifting outward in 4 slightly different directions, all of them carrying a map home, all of them scratched with the same style of lines and numbers, the same 14 beams of spinning stars. The galaxy is an address book, and we wrote our address 4 times just in case. Now, on the Voyager Record's cover, that pulsar map sits alongside a second clock. And the second clock is stranger, more intimate, and more patient. Glued to the aluminum cover of each record jacket is a small patch of metal. Not just any metal. The patch is electroplated with a specific isotope, uranium-238, and it is there for one reason only. It is a clock. Uranium-238 is radioactive. That means its atoms are unstable. They decay over time, each one eventually releasing particles and transforming step by step into other elements. Lead is the final product of that long chain of decay. The key fact, the one the committee was relying on, is that uranium-238 decays at a precisely known rate. Its half-life, the time it takes for exactly half of any given sample to decay, is approximately 4.47 billion years, almost 4.5 billion years to halve. A span so large the mind doesn't grip it easily. Earth itself formed about 4.5 billion years ago, so the uranium glued to the record's cover is just barely past one half-life since the solar system itself condensed. What this means for a finder is concrete. When someone picks up the record, whenever that is, if it ever happens, they can analyze the patch on the cover. They can measure how much uranium-238 remains and how much of its daughter products, the elements uranium decays into along the chain, are present in the patch. From that ratio, they can calculate how long the decay has been running. And since the decay started when the patch was made, when it was electroplated and attached to the cover in 1977, the ratio of uranium to its decay products tells them, in principle, how many years have passed since then. It's not a digital readout. It's not a number glowing on a screen. It's the slow, patient arithmetic of physics itself, written in atomic ratios. You measure what's there and what's gone, and the universe hands you the elapsed time. The half-life is long enough that the signal will still be readable for billions of years. Even after a billion years, most of the uranium will still be uranium. There will be a measurable change, a measurable ratio of products, but the decay won't be complete. The clock won't have run out. It will simply have ticked a certain number of times, and the ticks will be countable from the chemistry of what's left. So the cover carries 2 clocks, one astronomical, the pulsar map, whose spinning stars tick slower and slower across the centuries, they're slow down encoding the launch date for whoever can read it. And one nuclear, the uranium patch, whose slow atomic decay holds the same information written in a different language, the language of isotopic ratios and half-lives. Two independent methods, two entirely different physical processes, both arriving at the same answer. We made this here, and we sent it then. The committee didn't need to include both. One would have been enough. But they included both because they were thinking about redundancy, about the chance that one method might be inaccessible to a particular finder, that a civilization might have the chemistry to read uranium, but not the astronomy to catalogue pulsars, or might have the radio telescopes, but not the mass spectrometers. Two clocks on the same cover, in case one is unreadable. That's the level of thought that went into every square centimetre of that jacket. Let that settle for a moment. A gold-plated disc in an aluminum jacket bolted to a spacecraft drifting through interstellar space, its cover carrying a map made of stars and a patch of slowly dying uranium. Two different languages for the same one sentence. This is when we made this. This is where we live. Come find us, or simply know that we were here. And then beneath all of that, beneath the cover, beneath the instructions and the clocks and the maps, is the record itself. And on the record is something even more remarkable, a library. There are 116 images encoded in the grooves of the Voyager Golden Record. Not photographs in the usual sense, not pictures you could hold up to the light and see. They are something stranger and more ingenious than that. They are photographs translated into sound. Here's how it works. A picture is really just a grid of points, a matrix of positions, each with a brightness value. If you scan across the picture one horizontal line at a time, you can represent each line as a varying signal. Bright here, dark there, bright again, a long dark patch, and so on. That varying signal can be encoded as a varying electrical waveform. And an electrical waveform can be put into the groove of a phonograph record, just like music. The record doesn't know it's storing a picture, it's just storing a waveform. But if a finder plays that part of the record and interprets the waveform correctly, if they scan it out line by line and translate brightness into a point on a screen, they see a photograph. The cover diagram explains exactly how to do this. It shows the waveform pattern, the number of lines, the way the picture is built up. It shows a small sketch of what the correct result should look like, so the finder knows they've done it right. The first image they will decode is a calibration circle, a plain, simple circle drawn on a white field. If they play the opening of the image section and the result they reconstruct is a circle, not an ellipse, not a squashed or stretched shape, then they know their timing is right, their aspect ratio is correct. They're reading the pictures at the right speed, in the right proportions. The circle is a quiet test. It says, yes, you have it. And then the pictures begin. There are 115 photographs and diagrams plus that calibration circle for a total of 116. The committee thought carefully about how to sequence them, how to teach a potential finder about humanity, not in a jumble, but in a kind of logical progression, starting with the abstract and working toward the concrete, starting with the smallest building blocks and building outward to the world and the people who inhabit it. The sequence begins almost like a textbook. Before there are pictures of Earth or people or animals, there are diagrams, mathematical definitions, the physical units the images will use, a kind of primer, a vocabulary lesson, offered quietly before the story begins. If you're going to show someone a picture of a human being who is 1.7 meters tall, you first need to agree on what a meter is. The record establishes this. It shows the mathematical relationships that define the measurements it will use. It sets up a shared language, a shared frame of reference before it shows a single, recognizable thing. There is something patient and generous in that order. an acknowledgement that the finder might not share any of our assumptions about number or size or scale, and so the record offers to start from the very beginning. After the mathematical primer come diagrams of the solar system, the Sun and its planets arranged in order, their relative sizes indicated, their positions given. Earth is labelled. This is where we are. This is the system we orbit. These are our neighbours, the other bodies we share a star with. The planets are given in the context of what the cover's pulsar map has already shown. A finder who has located the Sun on the pulsar map can now zoom in and find the third planet, and know that is ours. And then the images begin to arrive closer. There are pictures of the Earth's surface, a seashore with sand and water and the line of the horizon, a desert, bare and enormous, the kind of landscape that goes on in every direction without apparent end. Mountains, white at their peaks, the simple geological fact of great height. These images aren't chosen to show beauty exactly, though they are beautiful. They're chosen to show variety, to show that the surface of this planet comes in many forms, that there is not just one landscape but many, that the same world that has deserts also has ice, that the same planet that has surf also has altitude. There are pictures of human construction. The Great Wall of China seen from a vantage point that makes clear its extraordinary length, the way it follows the ridgelines of mountains across hundreds of kilometers. The Sydney Opera House, its white shells rising from the harbour. The Taj Mahal, its symmetry and its reflecting pool. These are there to say that the creatures of this planet build things, that they gather materials and shape them according to plans they carry only in their minds, and the result sometimes lasts centuries. The Great Wall is thousands of years old in parts. The Taj Mahal was built in the 17th century. The Sydney Opera House was new when the record was made, 3 structures from 3 different eras, each representing the impulse to build something larger and more lasting than the individual life. And then the pictures move inward toward the body. There are diagrams of the DNA molecule, the double helix, the spiral ladder of base pairs, the structure that carries the instructions for building every living thing on Earth. For any civilization that has independently discovered the same molecule, this image would be instantly recognizable. For any civilization that hasn't, it is offered as a diagram, a structure to examine and perhaps eventually understand. Either way, it says, this is the code. This is the chemical basis of the life that made the record you're holding. There are diagrams of human anatomy, the skeleton, the internal organs, the structure of the body from the inside, a full body outline showing proportions, a male and female silhouette standing together, a nude man and a pregnant woman. The pregnancy is explicit in the diagram, the rounded abdomen and the small figure visible within it. This is how we reproduce. This is where new humans begin. This is the shape of the body that will grow and eventually become someone who might build a spacecraft and bolt a record to its side. Here there's a small human story woven into the choice. NASA in 1977 was aware that explicit imagery carried certain risks, not cosmic risks but earthly ones. The agency had faced public reaction to the Pioneer plaques, which had included small human figures shown without clothing. The committee working on the Voyager record navigated similar considerations and made the decision to present the human figures in silhouette form rather than as full photographic nudes. The pregnant woman and the man beside her are rendered as outlines, recognizable in their form but not explicit in their detail. A compromise between candor and caution made by people who were working in a particular moment of human culture and couldn't fully step outside it. The record is honest about human biology, but honest in the way that a careful, thoughtful person in 1977 might be, with one eye on the cosmos and one eye on the concerns of the time. There are pictures of the stages of human development. The fetus in the womb, small and curled, the features just becoming recognizable. The progression of growth from infancy onward. The arc of a human life from its beginning, offered as a sequence of images that moves through time, showing what it looks like to arrive in the world and grow. There are pictures of people eating, a person drinking from a glass, a person tasting food, the simple animal act of taking sustenance into the body. These were included to show something basic and universal about the beings who made the record, that they require food and water, that they take these in through an opening in their face, that the act of eating is one of the most fundamental and recurring events in any human life. There are pictures of people in groups, families, children at play, people working together. The images try to convey not just the individual human body, but the social nature of human life. That people live together, that they exist in relationships, that a human being alone is only part of the picture, and the full picture includes all the other human beings they're connected to. There's something quietly moving about trying to represent all of this in 115 images. The committee knew they couldn't show everything, couldn't show enough to fully explain what a human being is, what a civilization is, what it feels like to be alive on this planet. But they tried to show enough to make a start, to give a finder enough information to understand the shape of the thing, even if the details would remain mysterious. To say, here are our bodies, here is our planet, here is the structure of our biology, here are the things we build, here are the things we eat, here is the look of a child and a mountain and a wave breaking on a shore. We can't show you everything, but we can show you this. And because they were thinking about all of this as communication, as an act of translation across an inconceivable distance to a mind that might share nothing with our own, they sequenced it carefully, starting with the abstract and working toward the specific, starting with the logic that holds everything together and working toward the images of faces and landscapes that only make sense once the logic is in place. The mathematical primer first, the solar system second, the Earth's surface third, and then the life that lives on that surface, beginning with the chemistry of life, moving through anatomy, and arriving finally at the look of a living person. The images are, in a sense, the most generous thing on the record. The sounds are extraordinary and the music is extraordinary, but they are harder to decode, harder to interpret without cultural context. An alien might hear the music and not know what to make of it. But an image of a fetus, of a small human curled inside a body that is larger, clearly growing, clearly in the process of becoming, has a kind of directness that transcends language. It shows rather than tells. It makes an appeal to what might be a shared category, life, recognizable as life, even from a vast distance. You could spend a long time with any one of these 115 images. The seashore, for instance, what does it show? Water at the edge of land, the transition zone, the place where two very different environments meet. The horizon line far away, proving the planet's curvature in a simple, quiet way. If the horizon is that far below you and you're standing on flat ground, the planet beneath you is round. It shows the color of sky and sea in daylight, the texture of wet sand at a certain moment, a single frame, but inside it are dozens of facts about the planet. Or the Taj Mahal. It was built in the city of Agra, in what is now India, by the Mughal Emperor Shah Jahan, completed around 1653 as a mausoleum for his beloved wife Mumtaz Mahal. That history isn't in the picture, but the fact of it is there. The white marble, the long reflecting pool, the precise fourfold symmetry, the care taken. The image says, "We built this. Someone thought it was worth building." The care in the building tells you something about what the builders valued. You can read a civilization in the things it chooses to make permanent. The images together tell a kind of story if you read them in sequence. They begin in abstraction, mathematics, physics, the solar system, and end in particularity, people, faces, places, moments. They begin where any mind equipped with reason might begin and end somewhere that is specifically, irreducibly human. The committee was making a bridge, starting from the far shore, the universal language of physics and geometry, and building toward this shore where a woman drinks a glass of water and a child plays in the grass and a wall follows the ridgeline of a mountain for hundreds of kilometers. 115 photographs and diagrams plus one calibration circle. 116 images in all, encoded as waveforms in the groove, waiting to be recovered line by line, reconstructed into something like vision. And before any of them, the circle, the simple, plain circle that says, "You're doing it right. Keep going." The first image on the Voyager Golden Record is a test, a gentle invitation to trust the process, to verify before proceeding, to establish that the communication is working before the communication begins. It is, in its quiet way, one of the most careful things the committee did. Don't assume the finder got it right. Give them a way to check. It's the kind of thought that comes from imagining the finder, really imagining them with sympathy and patience. Imagining that they might be uncertain, that they might have tried to decode the image and gotten something strange, a smeared shape, an unrecognizable pattern, and not known if they were doing it correctly or if the record was damaged or if they simply didn't understand. And the calibration circle is the answer to that uncertainty. It's the quiet reassurance built into the structure. If you see a circle, you got it right. If you see something else, try again. We left you a check. We thought of your uncertainty. We tried to help. There's a word for that kind of thought, and it's something close to kindness. The Voyager record is often talked about as a scientific achievement, a feat of encoding and compression and engineering. And it is all of those things, but it is also, in its details, something that looks like care. The calibration circle is care. The stylus and cartridge bundled with the jacket are care. The two independent clocks, uranium and pulsars, are care. The mathematical primer before the photographs is care. The committee wasn't just encoding information, they were thinking about the receiver. They were trying to make the communication as easy as possible for someone who shared none of their context, none of their language, none of their assumptions. They were trying to be kind across an incomprehensible distance to someone they would never meet. In the dark of your room, that's a thing worth resting with for a moment. The people who made this object spent months thinking about the experience of a finder, a being they couldn't imagine, from a civilization they couldn't picture, in a future they couldn't name, and asking themselves, what will this person need? What will help them? What might confuse them? And how do we remove that confusion? What should come first and what should come after? And from that careful, patient asking, they got the calibration circle, the mathematical primer, the stylus in the jacket, the uranium on the cover, 2 clocks, not one, a map made of stars and a map made of atoms, both pointing home, both saying when. The record is still traveling. The images are still there, encoded in the groove, waiting in the dark. The calibration circle sits at the front of the queue, ready to tell whoever finds it. You got it right, you're reading this correctly, come in, there's more, keep going. The seashore is waiting in there, and the mountains, and the Taj Mahal in its long reflecting symmetry, and the double helix coiled in its patient diagram, and the fetus, small and forming, and the man and woman in silhouette, one of them carrying a new life inside her. All of it there, in the groove, in the waveform, in the slow analog scroll of a phonograph disc turning at 16 2/3 revolutions per minute in a room that for now is only the cold, dark between the stars. The images are the beginning of something. The record doesn't stop there. After the images, after the visual library of 116 encoded pictures, there are voices, human voices, dozens of them recorded in a room at Cornell University in the spring of 1977. Voices saying hello, saying welcome, saying something gentle and brief in the language each speaker grew up speaking, in the language they first learned to make sense of the world. 55 languages, and the sequence in which they appear is not alphabetical, not political, not arranged by the number of speakers in the world. The sequence moves backward in time. The greetings begin with the oldest languages the committee could find still recorded and spoken, the languages farthest from us in time, reaching back toward the dawn of human writing and speech. It opens with Akkadian, and that's where we're going next. Into those voices, those 55 hellos, some of them from languages that barely anyone in the modern world knows, some of them from the most widely spoken tongues on Earth, all of them brief, all of them warm, all of them saying something that amounts to the same thing. We are here, and we are glad to reach you, and we hope you are well. But for now, let the images rest. Let them sit there in the groove where they've been sitting since 1977, the calibration circle at the front, the rest following behind it in their quiet, patient sequence. The numbers first, then the solar system, then the Earth, then the body, then the face. All of it traveling outward, somewhere past the edge of what the sun can reach. In the jacket, with the pulsar map and the uranium clock, the stylus bundled alongside in case it's needed. Let it all rest in the dark, and let yourself go soft wherever you are, in whatever light is still on or has gone out, on whatever surface you've settled into for the night. The record is still going. It will be going when you wake. It will be going for longer than you can comfortably hold in your mind, and every single image is still in there, waiting, intact, in the gold. Akkadian, not English, not Mandarin, not any of the big, sprawling highway languages of the modern world. The first hello on this record, the first voice an unknown finder would encounter after the greetings section begins, speaks a language that was already ancient when Rome was new. Akkadian was the tongue of ancient Mesopotamia, spoken in the land between the Tigris and the Euphrates, in the cities of Babylon and Nineveh, inscribed in wedge-shaped marks pressed into clay tablets by scribes who could not have imagined an aluminum jacket hurtling through interstellar space. And yet there it is, an Akkadian voice, human and warm, on the Voyager Golden Record. The committee that built the record made a deliberate decision when they arranged the spoken greetings. They did not lead with the languages most people on Earth speak. They did not open with English or Mandarin or Spanish or Arabic, the great rivers of human communication that carry billions of people's thoughts every day. Instead, they turned and walked in the other direction. They walked backward through time. The greetings open with the oldest human languages still recoverable, still recordable, the languages closest to the root of the tree, and they move from there forward toward the present. It is a quiet, elegant act of respect, the idea that antiquity matters, that the oldest voices deserve a place at the front. After Akkadian comes Sumerian. Sumerian is older still in some ways. It is one of the first written languages we know of anywhere on Earth. The people who spoke it lived in the southern part of Mesopotamia, in cities like Ur and Eridu, thousands of years before the Common Era. They invented a writing system, pressed their thoughts and their accounts and their stories into clay, and eventually their language stopped being spoken as a living tongue. But it was preserved in those tablets, and scholars have reconstructed enough of it to record a spoken greeting, and that greeting is on the record, Sumerian, tucked into the groove, pressed into the gold, and then Hittite, Hittite was spoken in Anatolia, in what is now modern Turkey, by an empire that rose and fell more than 3,000 years ago. The Hittites left extensive written records, contracts and treaties and royal correspondence, and linguists have worked out enough of the spoken language to give it a voice again. That voice, too, is on the record. Think about what the committee was doing. They were not just including old languages as curiosities or as proof of scholarly range. They were making a statement about the depth of the human story. If a finder ever comes to this disc and decodes those early greetings, they will hear voices that represent the beginnings of recorded human thought. Not the middle, not the recent flourishing, but the beginning. The first scratches we made on the surface of time. The committee wanted whoever finds this record to know that we are old, that we have been at this for a long time, that the version of us sending this message is not the first version, that behind us stretches a long, quiet history of people speaking to each other, of people leaving marks for others to find. The greetings were recorded at Cornell University, where Carl Sagan held his position. Speakers came to the recording studio one by one or in small groups and spoke their hellos into a microphone. Some of the ancient language greetings required specialists, scholars who had spent years reconstructing how those languages sounded. Others were simply members of language communities who agreed to participate. Each greeting is short. Most of them run only a few seconds, a sentence or two at most. But together, the 55 of them form a kind of choir, a brief human sound in 55 different keys. The sequence moves forward in time from those ancient voices, Akkadian, Sumerian, Hittite, and then onward through the long catalogue of human language. There are greetings in many of the major languages of the ancient and classical world, and then in the languages that spread and diversified as civilizations rose and fell and mixed and spread. The committee chose languages that represent the breadth of human linguistic experience, trying not to overweight any single region or any single era. By the time you reach the modern entries in the sequence, you are already in what feels like familiar territory, though every one of the 55 greetings carries the same quiet weight. Someone speaking to the unknown. And then there is English. The English greeting is brief. It is simple. It does what it needs to do, and nothing more. But the English voice on this record is not a diplomat's voice, not a news anchor's voice, not the careful, rounded vowels of someone trained to project authority. The English greeting on the Voyager Golden Record belongs to a child. His name is Nick Sagan. He was Carl Sagan's son, and he was approximately 6 years old when he stood in front of the microphone at Cornell and spoke the words that would leave the solar system. His line is, "Hello from the children of planet Earth." That is all. 7 words, and yet there is something in those 7 words that is hard to sit with quietly. A 6-year-old boy in 1977, with no particular understanding of what he was being asked to do, not really, not the way an adult understands the stakes of a thing, simply speaking a hello, a child's hello. The most uncomplicated, open-hearted version of a greeting possible, because it comes from someone who has not yet learned to be guarded. And that hello is now farther from him than light can travel in a year, still moving outward, still carrying his young voice into the dark. He grew up. Nick Sagan became a writer, worked on Star Trek. The next generation lived an adult life. And somewhere out past the edge of the heliosphere, his 6-year-old voice is still going. 7 words, a lifetime away, getting farther every second. The Mandarin Chinese greeting on the record is warm in a different way. Warmer, in a certain sense, than you might expect from a formal interstellar communique. It translates roughly to something like, "Hope everyone's well. We are thinking about you all." Please come here to visit when you have time. Come here to visit when you have time. It sounds like something you would say to a relative who lives a long drive away. Come over when you can. We'd love to see you. And of course, the being who might one day decode this greeting would not be a relative, would not have a car, would not be doing anything as simple as making a long drive. But there is something very human in the casualness of that invitation, the assumption or the hope or the simple reflex of hospitality that the finder is someone who could come by, someone who might say yes. Several of the greetings carry this note. A few of the speakers, perhaps not fully grasping the abstract enormity of what the record actually is, offered invitations that feel domestic, neighborly, warm. Come visit. We hope you are doing well. We are thinking of you. These are the things people say to each other, and these particular people said them to the universe. The Amoy greeting, Amoy being a form of Minnan, a dialect spoken in parts of southern China and Southeast Asia, wishes the listener peace, health, and happiness. Not complicated, not formal, just those three things: peace, health, happiness. The basic wishes, the ones you would put on a card or say at the end of a phone call or press into the hand of someone you might not see again for a long while. 55 languages, 55 short moments of a human voice saying in its own way the same thing. We are here. We wish you well. We hope this reaches you. Then there are the official voices. Among the 55 spoken greetings and alongside them in the record's overall design come the more formal representatives of humanity. The record carries a statement from the Secretary General of the United Nations, who at the time of the record's creation in 1977 was Kurt Waldheim. His message speaks on behalf of the member nations of Earth, framing the record as a greeting from the peoples of the world collectively, not from any single nation, not from any political alignment, but from humanity as a represented whole. And there is a message from the President of the United States. Jimmy Carter's statement is not a spoken greeting on the record itself, but rather a printed message, part of the accompanying materials of the project, part of the wider context in which the record lives. But it is among the most quoted things associated with the Voyager Golden Record, and it is worth holding quietly for a moment. Carter's message is dated June the 16th, 1977. He describes the record as, in his words, a present from a small, distant world. And he goes on, the record is a token of our sounds, our science, our images, our music, our thoughts, and our feelings. Our sounds, our science, our images, our music, our thoughts, and our feelings. That last one, our feelings, not just what we know, not just what we have built or discovered or measured, what we feel. The inclusion of that word in a presidential statement about an artifact leaving the solar system says something about what the people who made this object believed they were doing. They were not sending a report. They were not sending a textbook. They were sending something that specifically included the emotional interior of human life, which is, as it happens, quite literally true. But we will get to that. For now, let the greetings settle. 55 of them, from Akkadian at the front to the languages of the modern world, a 6-year-old's voice in the middle saying hello from the children of planet Earth, warm invitations and formal statements, and quiet wishes of peace and health, all pressed into the groove, all riding the disc out beyond the reach of the sun. After the greetings, the record moves into a section with no words at all. It is called The Sounds of Earth. It runs for approximately 12 minutes. There are no voices explaining what the sounds are, no narration, no labels, just sounds. The raw sensory texture of a planet assembled into a sequence. The committee made a particular decision about how to arrange these sounds. They did not simply pick their favorites, or the loudest, or the most immediately recognizable. They arranged them in a rough chronological order, not chronological by when the recordings were made, but chronological by what the sounds represent in the history of this world. They begin with the Earth itself, with the planet as a geological object, and they move forward through the emergence of life, through the arrival of humans, through the long arc of what we have built and done. It begins with what might have sounded like Earth, long before anything alive was here to hear it. Volcanoes. The deep rolling sound of a volcano, the kind of sound that was the signature of a young planet still finding its shape, still adjusting, still releasing the pressure of its interior through the cracks and vents in its crust. Volcanoes shaped Earth long before there were eyes to see them or ears to hear them. They filled the atmosphere. They built islands. They are part of how the world made itself into the world, and so they are the first sound on the Sounds of Earth montage. Then earthquakes. The low, grinding rumble of the ground shifting under itself, tectonic plates pressing and releasing, the planet still in motion. An earthquake is the Earth reminding you that the solid ground is not as solid as it seems, that it is resting on something that moves. And then thunder. Thunder is a sound that a very young child might think of as frightening, but in this context, in the context of this montage, this careful sequence, it comes across as something almost gentle. Thunder is just sound. It is the sound of electrical discharge in the atmosphere, the sound of a storm, and storms are part of what keeps the world alive. Thunder means rain, and rain means rivers, and rivers mean the next sound on the montage, wind. Wind, that oldest and most constant of Earth's voices, wind over open ground or through a forest canopy or across a body of water, the sound of moving air, the atmosphere in motion, the planet breathing in and out in its own slow, enormous way. Wind is one of the sounds that was here before us and will be here after us. It does not care about our presence or our absence. It moves because pressure differences in the atmosphere move it, and it has been moving since Earth had an atmosphere to pressurize. Rain. The sound of rain, of water falling out of the sky and meeting the ground. Rain is one of those sounds that many people find easier to sleep to than silence. There is something in the pattern of it, irregular but constant, many individual drops but united into a wash of sound, that the brain finds soothing. It appears on the Voyager Golden Record because rain is essential to how Earth works. Without the water cycle, without rain, the surface of this planet would be very different. Rain is life, and there it is in the groove, preserved in gold. Surf. The sound of ocean waves, the slow rise and fall of water meeting land, the rhythmic push and pull that has been happening on every ocean coast of this world for longer than anything alive has been here to hear it. Surf is another sound that people sleep to deliberately, that people record and play back on devices to help themselves drift off. There is something about that rhythm, not quite regular, not quite irregular, always moving, that matches something in the human nervous system. And now the ocean surf of Earth is on a disk between the stars. After the geological and atmospheric sounds, life arrives. Small sounds at first. The sounds of the biosphere. Birds. The record includes birdsong, not a particular species named with precision in most sources, just birds, the mixed, layered, overlapping quality of a place where birds are calling. Birds are among the most constant background sounds of the living Earth. They are on every continent except Antarctica. They fill every kind of habitat they call at dawn and at dusk and through the day. The sound of birds is one of the most recognizable signs that a place is alive. And a hyena. That detail always surprises people a little. Not a lion, not an elephant, not one of the large, charismatic animals that tend to appear on lists of remarkable things. A hyena. Specifically its call, which is one of the more unusual sounds a mammal makes. Not quite a bark, not quite a laugh, something between the two, unmistakably alive, unmistakably animal. The hyena made the cut. It is on the record. And then moving through the sequence comes one of the most deliberate placements on the entire montage, the humpback whale song. The team that built the Sounds of Earth section did not place the whale song among the strictly geological sounds. They did not place it among the general animal sounds. They wove it in near the human greetings. They placed it there on purpose. The choice was intentional, and its meaning is not hard to read. The humpback whale sings. Male humpbacks produce long, structured, evolving sequences of sounds, low moans and high squeaks and everything between, that go on for hours and change over time across entire populations. They are not random, they have structure. They are, in some sense we do not fully understand, communication, not language the way we use the word, but not simply noise either, something in between, something that matters to the whales who make it. By placing the whale song near the human greetings, the committee was suggesting, quietly, without stating it directly, that the languages of Earth are not only human, that when this record arrives, if it ever arrives, and whoever or whatever receives it begins to work through the greetings, what they will find is not a section of human voices followed eventually by animal sounds as an afterthought. What they will find is human voices and whale voices side by side, both given a place of honor, both presented as if they count. The humpback whale has been on Earth longer than our species. Its lineage stretches back tens of millions of years. We have been here, in our present form, for a fraction of that time. And yet here we are, putting the whale's voice on a record and sending it beyond the solar system, as if to say, this voice also belongs to Earth. This voice also comes from us, in the broadest sense. We are not alone on this planet, and we wanted you to know that. After the whale song, the montage moves into unmistakably human sounds, the sound of a human heartbeat, steady, rhythmic, patient. The fundamental sound of a living person, be not the voice, not the breath, but the pump at the center, moving blood around the body at a rate of roughly 60 to 80 times a minute in a resting adult. The heartbeat was included because it is so immediate, so intimate. It is not a sound you make, it is a sound you are. It was there before you could speak, before you could think, before you were born. It will be there, if you are well, for every moment of your life until the last one. A heartbeat on a golden disc between the stars, and footsteps, the sound of a person walking. The particular rhythm of a bipedal animal moving through space on 2 feet, the sound that follows you everywhere you go. Footsteps and a heartbeat together, not quite simultaneous, but close enough in the sequence to create a picture. A living person, moving. Then a kiss, soft, brief, human. An intimate sound, the kind of sound that is not made for an audience, that is not a performance, it is simply what it is. 2 people close enough to each other that this sound happens. And it made the cut. The committee chose to include it. They sent it, pressed into the gold, out into the universe. Someone on that committee thought the universe should know about kissing. And then a baby, the sound of a newborn or a very young infant in the first moments of sound that a new human life makes in the world. The cry of a baby is one of the most biologically arresting sounds a human can hear. It triggers something immediate and non-negotiable in most people, a pull of attention, a reflex of concern. The baby is here. The baby needs something, and following the cry, the sound of a mother soothing it, soft sounds, the close, warm sounds of comfort being offered. A voice very close, very gentle, doing the thing that voices do in the very first days of a human life. The sequence is extraordinary when you hold it all together. Volcano, rain, surf, birdsong, whale, heartbeat, kiss, baby. each one a step further into the human, each one more intimate than the last. The montage starts with the deep geological time of the planet and ends with the most personal and interior sounds of a single human life. After those intimate sounds, the montage moves outward again into tools, the sound of a saw, the back and forth rhythm of a blade moving through wood, a sound that humans have been making for thousands of years, that echoes with the idea of making something, building something, shaping raw material into something else, an axe. The sharp, clean sound of a blade meeting wood, the sound of a forest being harvested, of a fire being laid, of the basic human act of using a tool to transform the world. A hammer, the strike of metal on metal or metal on wood, the sound of assembly, of construction, saw, axe, hammer, the basic kit. The earliest and most essential instruments of human making, before engines, before electricity, before anything digital, just the hand tools, the sounds that humans made for millennia before they made anything else. And then something quite specific, something chosen with deliberate care. Morse code. The record includes the sound of Morse code, dots and dashes, the language of the telegraph, the signal system that humans used for over a century to transmit messages across vast distances before wireless voice transmission became possible. Morse code is itself a kind of symbolic language, a mapping of letters onto patterns of short and long signals, and it appears on the record as another layer of communication, another demonstration of how humans encode meaning. But what the Morse code on the Voyager Golden Record actually spells out is not arbitrary. It spells out a Latin phrase, ad astra per aspera, to the stars through hardships. It is, when you sit with it, an almost achingly appropriate thing to encode in a record being sent to the stars. To the stars through hardships, through the work, through the difficulty, through the long labor of understanding enough science and engineering to build something that can leave the solar system. Through all of that, to the stars. The phrase is old, the sentiment is ancient, and someone chose to etch it into the record in the code that humans used to send their first long-distance messages. There it is, in the groove, in dots and dashes, going wherever the record goes. After the hand tools and the Morse code, the montage moves into the sounds of modern human transportation, the sounds of the machine world, a train. The particular sound of a train, the rhythm of wheels on track, the sheer mechanical regularity of it, the low rumble and the higher squeal, the way a train sounds like organized motion, like something large and purposeful, moving through the world on a fixed path. Trains were among the first modern machines to move people and goods across great distances at speed. The sound of a train is the sound of the industrial era arriving, an automobile. The sound of a car engine, the sound of internal combustion, of a machine that burns fuel and converts it into motion. The automobile reshaped human settlement patterns, changed the geography of cities, made distances that once took days passable in hours. Its sound is one of the background textures of modern life in much of the world. Aircraft, the deeper, broader sound of flight, the roar of engines lifting something heavy into the air, the sound of the atmosphere being pushed aside by human will and engineering. Aircraft are the most recent form of human transportation on the list, the most recent addition to the soundscape of the world. A century before the record was made, no such sound existed anywhere on Earth. Now it is one of the most recognizable sounds in human experience. And then at the end of the transportation sequence, a sound that is in a category entirely its own. The launch of a Saturn V rocket, not a small engine, not a car, not an airplane, a Saturn V, the largest rocket ever flown successfully, the machine that carried Apollo astronauts to the moon, producing roughly 7.5 million pounds of thrust at liftoff, a sound so enormous that it is not really comparable to anything else in human experience. People who were present at Saturn V launches have described the sound as physical, as something that moved through their bodies as much as through their ears, a low-frequency roar that you felt in your chest and your bones. The sound of the Saturn V is the sound of the most extreme form of human transportation leaving the planet. It is the sound of escape velocity being achieved, and it is on the Voyager Golden Record, itself launched by a rocket, itself a thing that has now left the solar system, which means the sound of the rocket that represents our first steps beyond Earth is now traveling, encoded in a groove, beyond Earth in exactly the way those first steps gestured toward. The Saturn V launch ends the Sounds of Earth montage. 12 minutes, volcano to rocket, the deep geological past to the moment of departure. The whole arc compressed into a dozen minutes of sound, moving from the planet, making itself to the species, launching itself off the planet and into space. There is something quiet and enormous in that arc. It took billions of years for this planet to go from cooling volcanic rock to a civilization capable of launching a Saturn V. The record compresses all of that into 12 minutes and then sends those 12 minutes into the dark. The Sounds of Earth section of the record is complete. And the montage sits there in the groove, after the greetings, after the hello in Akkadian and the hello from the 6-year-old child, and the warm Mandarin invitation, and the official words of Kurt Waldheim, and the printed words of Jimmy Carter. All of it layered there, the planet speaking in every register it knows, from the geological to the intimate to the mechanical. Think about the people who made these decisions, the committee that chose which sounds to include, in which order, for how long. They were not just making a playlist, they were making an argument about what Earth is, about what is essential to understanding this place, about what you would want a stranger, a profoundly, incomprehensibly strange stranger, to know about the world you come from. They included thunder, they included a kiss, they included a baby crying, they included a hyena, they included Morse code, spelling out a Latin phrase about going to the stars through hardships. They included the launch of a Saturn V, the sound of humanity first achieving escape velocity. Every single choice in that list was a decision. Someone said, this one, this sound. And all of it is there now, in the aluminum jacket with the pulsar map and the uranium clock, the stylus bundled alongside, somewhere past the edge of the sun's reach. Let the montage play in your mind for a moment. Volcano, rain, surf, birds, hyena, whale, heartbeat, footsteps, kiss, baby's cry, and a mother's voice close and soft, saw, axe, hammer, dots and dashes spelling to the stars through hardships, train, car, aircraft. And then the Saturn V, its roar spreading out in all directions as it climbed, as it always climbed, with that enormous sound that you felt in your sternum. 12 minutes, and then quiet, and then music. That is what comes next. After the images, after the greetings, after the sounds, the music begins. And the music is the longest section of the record, the section that takes up the most time, roughly 90 minutes of selections gathered from the full reach of human musical tradition. It is the section where the committee had to make its hardest choices because music is the thing that humans make that is the most immediately purely felt. And they had 90 minutes to represent everything. But the music is where we are going next, and it deserves its own quiet attention. For now, let the sounds of Earth rest where they are. Let the whale's song sit there in the groove. Let Nick Sagan's voice rest in the gold. Let the Akkadian greeting and the Sumerian greeting and the Hittite greeting sit at the front of the sequence, where the committee placed them at the very beginning of the language section, as close as recorded sound can get to the beginning of human language. Let the volcano sit there, and the rain, and the surf, and the footsteps, and the kiss, and the baby, and the Morse code dots and dashes, and the Saturn V with its enormous climbing roar. It is all there. It has been there since 1977. It is there right now in the jacket with the stylus, in the dark, moving. And the night is long and you are somewhere comfortable in whatever quiet your particular corner of the world offers at this hour. And there is no need to hold all of this in your mind at once. No need to catalogue it, or memorize it, or even stay quite awake for it. The facts will still be here when morning comes. The record will still be going. You could close your eyes now if you wanted. The sounds of Earth have already played. They played over 50 years ago in a studio at Cornell, and they are playing still, in a sense, encoded in gold, somewhere between here and forever. Let yourself go soft with that. The heartbeat on the record is still beating in its way. The baby is still crying in its way, and the mother is still soothing it, close and warm. The whale song is still threading itself through the darkness between the human voices, placed there, deliberately placed there, to say that the languages of Earth include more than ours. It is a gentle thing when you think about it, a gentle thing to have done, and the music is coming. The music is the longest section on the record. Roughly 90 minutes of it, more than anything else, more than the images, more than the greetings, more than the sounds. If you were to sit with the record from beginning to end, the music would be the place where you stayed longest. And the committee chose it that way deliberately. Music, they felt, was the part of human expression most likely to speak across any gap. Not words, which require a shared language, not images, which require shared visual culture. Music, and the thing we make with air and vibration and time, carries something underneath the information, something that might translate. So the music opens. And it opens with Bach. Johann Sebastian Bach is more represented on the Voyager Golden Record than any other single composer. 3 pieces chosen from his enormous body of work. 3 separate moments from the life of one man who died in Leipzig in 1750 and who could not possibly have imagined any of this. The very first piece of music on the record, the one that follows the sounds, that follows the volcanoes and the rain, and the Saturn V, is the first movement of the Brandenburg Concerto No. 2 in F major. It begins the music section. Whatever else a finder might think of the rest, Bach is the first thing they hear. The high, bright trumpet cutting through, the other instruments gathering around it, the whole concerto moving with that particular kind of joy that Bach had. Ordered, intricate, enormous, and somehow, despite all its complexity, light. Bach was chosen partly because his music is so structurally dense that it seemed to contain, within itself, a kind of argument about the nature of pattern and order. A being who understood mathematics and harmony might hear the Brandenburg and recognize that whoever made this was working with something systematic, a grammar almost, a logic of sound. The second Bach selection is from the Partita No. 3 for solo violin, a single violin, no orchestra, no accompaniment, just one instrument, and the decisions of one performer. This version was played by Arthur Grumio, a Belgian violinist whose recording carried the piece with a particular clarity, each note clean and separate, and then folding into the next. There is something remarkable about choosing solo violin for a message to the cosmos. One instrument, one human hand, one bow drawn across strings. Out of all the sound humanity has ever made, that particular quietness is on the record too. And the third Bach piece is the Prelude and Fugue in C from the Well-Tempered Clavier, Book 2, played by Glenn Gould. Glenn Gould, who was famously particular, who famously hummed along to his own recordings, who gave up live performance entirely in 1964 because he felt the recording studio was the purer place. His version of Bach is on the Voyager record, traveling now in the dark between the stars. His particular interpretation, his specific fingers, his tempo, the choices he made in a recording booth in the 20th century, all of it encoded in the groove of a gold-plated copper disc that has never come home. After Bach, Beethoven. Two pieces by Ludwig van Beethoven. The first is the opening movement of the Fifth Symphony with that sound, those four notes, the short, 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 long, that is probably the most recognizable musical phrase in Western classical music. On the record, it sits alongside pygmy songs and shakuhachi flutes and a Bulgarian woman's voice, just one piece among many. Enormous and famous and placed without ceremony next to things most people have never heard. The second Beethoven piece is the Cavatina from the String Quartet No. 13 in B-flat major, Opus 130. This one was placed near the end of the music section, deliberately. It is a slow, gentle, somewhat aching movement, and there is a story about it that Beethoven wept while composing it. Whether that is precisely true is difficult to say, but it is what is recorded about the piece, and the committee knew it, and they put it near the end, near the close of the music, where the last emotional note would be something quiet and something deep, rather than something triumphant. The Cavatina doesn't announce itself, it doesn't insist, it just arrives and it holds something and then it releases it, and when it is over there is a particular kind of silence that feels earned. The committee chose it as a kind of farewell within the music, the last long breath before the record's musical section draws to a close. Between Bach and Beethoven, there is Mozart. The aria is Der Hölle Rache, the Queen of the Night aria from the Magic Flute. Soprano Edda Moser sang it for the record. It is one of the most technically demanding arias in the entire operatic repertoire, a cascade of rapid, precisely placed high notes that requires extraordinary control and a voice capable of things most voices cannot do. If you have heard it, you know what it is. If you haven't, imagine the highest point your voice can reach, and then imagine someone moving above it, quickly, cleanly, without apparent effort. The choice of this particular Mozart aria tells you something about what the committee was willing to do. They didn't choose the most serene or accessible Mozart. They chose something that shows the extreme of what a human voice can accomplish, a kind of showing off in the best possible sense. Look what we can do. Look what one person can do with sound and breath and practice and a body. And then there is Chuck Berry. Johnny B. Good is the only rock and roll song on the Voyager Golden Record. One track from 1958, one man with a guitar, that particular rhythmic urgency that rock and roll carries. The choice was debated within the committee. Some felt that rock and roll was too juvenile, too ephemeral, too much of a cultural moment rather than a lasting human expression. Carl Sagan reportedly responded to that concern by pointing out that there are a lot of adolescents on the planet, and the song stayed. There is something quietly wonderful about this. Among the Bach and the Beethoven and the Mozart, among the Georgian choral music and the ancient Chinese guqin and the pygmy initiation songs and the Indian ragas, there is Chuck Berry, the energy of rock and roll encoded alongside the Brandenburg Concerto, both true, both human, both on the same disc, now traveling through interstellar space. The song begins and it just goes. That immediate forward motion, that particular propulsion, you could hear it next to almost anything and it would still be itself. It does not apologize for what it is. Now, after the rock and roll, something entirely different. Dark was the night, cold was the ground, by Blind Willie Johnson. Recorded in 1927 in Dallas, Texas. It is a slide guitar piece with a wordless humming vocal, No lyrics in any conventional sense, just sound and breath and something that resists being named. It is among the most unusual selections on the entire record, and Druyan chose it. She has spoken about why. She felt it captured something she couldn't find in words. Human loneliness. Human longing. The specific feeling of being alive and aware and alone in the dark and reaching towards something without quite knowing what you're reaching for. She felt that if any piece of music on the record conveyed what it feels like to be human at the level beneath language, it was this one. Blind Willie Johnson died in 1945, likely from pneumonia, reportedly after his house burned down, and he slept in the ruins. He was, by many accounts, already blind and without resources. His recording of Dark Was the Night is on a spacecraft that has left the solar system. The particular texture of that slide guitar, the particular sound of that voice, is traveling now where nothing made by human hands has ever gone. You could think about that for a while if you wanted to, or you could simply let it drift past like a piece of music playing in another room. The record includes a Navajo night chant, indigenous American music, the particular sound of the American Southwest, ceremonial and old. The committee made a deliberate effort to reach beyond what we might call the classical Western tradition. The Navajo night chant is there not as an exotic inclusion, but as an equal presence. Chakrulo is a Georgian polyphonic choral song. Georgian, meaning from the country of Georgia in the Caucasus, a small and ancient place with a choral tradition, unlike almost anything else on Earth. Georgian polyphony involves multiple voices moving independently, each line finding its own path while somehow, and this is the remarkable part, fitting with all the others. The effect is dense and resonant, voices braiding together in a way that can sound, to an unfamiliar ear, almost architectural. Chakrulo is one of those pieces. There is a Pygmy girl's initiation song from what was then called Zaire, which is now the Democratic Republic of the Congo, African vocal tradition. High voices, a particular kind of interlocking rhythm, the sound of a ceremony marking a specific moment in a specific life. It is on the record, it is between the stars. Flowing Streams, in a Chinese liu shui, is a piece for the guqin, a seven-stringed zither that is one of the oldest instruments in Chinese musical culture. The version on the record was performed by Quan Pinghu, a master of the instrument whose playing was considered among the finest of his era. The tradition behind the piece is roughly 2,500 years old. The particular technique, the particular tones that a guqin makes, strings pressed against a lacquered wooden body, producing sounds that are part pitch and part texture, has been part of Chinese cultivated life for a span of time longer than most Western musical traditions have existed. The committee chose it as one of several deliberate inclusions of the world's longest-standing musical cultures. Whatever a finder might conclude about humanity from Johnny B. Good, they could also conclude something else entirely from Liu Shui. Both are true. Both are us. From India, the record holds Jat Kahan Ho, a raga performed by Kesabai Kirkar. Kesabai Kirkar was a vocalist in the Jaipur Atrauli Gharana, one of the major stylistic lineages of Hindustani classical music. She recorded prolifically in the mid-20th century, and she was considered among the great voices of her tradition. By the time the Voyager record was assembled, she had already passed away. Her voice is on the record from an earlier recording. She did not know she was going to space. She has been going since 1977. Indian classical music is among the most elaborate and technically demanding vocal traditions on Earth. A raga is not a fixed melody in the Western sense. It is a framework, a set of notes and ornaments and rules about how and when to use them, within which a performer improvises. The performance Kesabai Kirkar gave in its particular moment, with its particular choices, is what was preserved, that specific improvisation. That specific morning or afternoon when she sang, Valia Balkanska sang the Bulgarian folk song Izlel Jedelio Hajdutin. Bulgarian folk singing, particularly in the tradition this piece comes from, involves a very specific kind of voice, open, direct, without the controlled vibrato of Western classical training, with a quality that can seem to cut through silence in a way that is difficult to describe. Balkanska's voice in this recording has been described by those who know it as piercing. That is the right word. It pierces. There is something unguarded about it, something that does not prepare you with artifice before it arrives. It is one of the tracks people remember after hearing the record. Not always the one they expected to remember, but it stays. From Australia, the record carries Morning Star and Devil Bird, songs from the Aboriginal musical tradition. The Aboriginal peoples of Australia carry some of the oldest living continuous cultural traditions on Earth, some of which may extend back tens of thousands of years. The music on the record represents a fraction of that depth, but it is there. The sound of that continent, that ancient habitation, is moving now through a silence older than the species that made it. Louis Armstrong and his Hot Seven play melancholy blues on the record. American Jazz from 1927, the same decade as the Blind Willie Johnson recording. Armstrong's trumpet, the particular looseness and precision that he had, the way jazz of that era moved, it is there alongside everything else, not above it, not below it, equal to it in the committee's accounting. And the Mexican mariachi piece, El Cascabel, performed by Lorenzo Barcelata. Mariachi music, with its particular instrumentation, its rhythmic confidence, its bright and carrying sound, Latin American popular tradition takes its place in the sequence. From Japan, the record carries Tsuru no Sugimori, crane's nest, played on the shakuhachi, a bamboo flute whose sound is among the most distinctive in East Asian music. The shakuhachi is played by blowing across the top of the instrument rather than into a reed, which gives it a breathy, sometimes rough, almost human quality. It can sound like wind, it can sound like breath. Tsuru no Sugimori is a traditional piece, and the sound of the shakuhachi playing it, that particular combination of note and breath, is encoded in the groove of the record, alongside Bach and Chuck Berry, and the pygmy voices and Valia Balkanska's piercing clarity. All of it there. There is something that happens when you hold all of these in mind at once, Bach and Blind Willie Johnson, and the Guchin, and the Navajo night chant, and the shakuhachi. The world is enormous, the world is old, the things we do with sound and time are almost beyond counting. And someone decided to put a small, careful sampling of that enormousness onto a 12-inch copper disc and send it out into the dark, where it will travel longer than we can meaningfully imagine. You could call that hopeful. You could call it something else. Mostly it seems like something that could only come from a species that cannot quite help itself. A species that, given the opportunity to say something to the universe, decided to say, listen. And now, after all the music, after the Brandenburg and the Bulgarian voice and the blues and the Guchin, there is something else on the record. Something that almost no one talks about. Something that was included not as a sound or a greeting or a diagram, but as a kind of transmission from inside one specific human body on one specific afternoon in the summer of 1977. It is the EEG and the EKG of a single person, the electroencephalogram and the electrocardiogram, the electrical patterns of one human brain and one human heart, recorded and encoded into the audio signal of the disc. The person is Anne Druyan. Druyan was the project's creative director. She helped choose the music, helped shape the record's contents, worked alongside Carl Sagan and Frank Drake and Timothy Ferris and Jon Lomberg through the months of assembling what would become this object. She was, by all accounts, essential to the character of what the record became. And then she volunteered her own brain. For roughly 1 hour, Druyan meditated while her brain activity was recorded. She had a plan for what she would think about during that hour. She moved through a sequence: the history of Earth, the history of civilization, the development of human knowledge and culture, and finally, at the end of the hour, her own feelings. Specifically, what it felt like to be in love. She has spoken about this. She and Carl Sagan had become engaged just days before the recording session. This was new. They had been colleagues, they had been friends, and then very recently they had realized something else, and that something else was present in her mind when she lay down to have her brainwaves recorded for a message to the stars. She was thinking about what it felt like to fall in love. That is what the EEG data carries, to whatever degree brainwave data can carry the content of a thought. It is the electrical signature of a human being in the first days of love. That data is encoded in the groove of the record. Druyan and Sagan married after the Voyagers launched. They remained married until Sagan's death in 1996. The brainwave recording she made in 1977, in the early days of that love, is now in interstellar space. It is on both records, on Voyager 1 and on Voyager 2, 2 copies of that one afternoon. Whether a finder could ever decode it into something meaningful, into anything resembling a thought or a feeling, is unknown. Druyan herself has acknowledged that. The data is there, genuinely encoded, but what a sufficiently advanced civilization might do with it, or whether any civilization could ever locate it and listen at all, is an open question that has no answer. But the data is there. That is the remarkable thing, not theoretically, not symbolically. The actual electrical patterns, real. She has described the decision to meditate on love during the recording as something deliberate, a choice. She wanted the record to carry not just the cultural outputs of humanity, the music and the greetings and the images, but something from inside a single human body during a moment of specific and private feeling. Something intimate, something that couldn't be paraphrased. It is easy to underestimate this. It sounds like sentiment, but consider what it means practically. Among all the careful, committee-deliberated decisions about what to include on the Golden Record, this one came from one person choosing to be the message rather than merely choosing the message. The record carries her heartbeat. The record carries the electrical signature of her brain during an hour of thought. Whatever is encoded there, it is as close as any artifact has ever come to carrying a human being's interior life into space. Almost nobody mentions this when they talk about the Voyager record. The Chuck Berry track gets mentioned, Carl Sagan gets mentioned, the message to aliens framing gets mentioned. But Anne Druyan's brainwaves, the hour she spent thinking about the history of the world, and then about being in love, the EEG and EKG encoded in the groove, this is quieter. This is the fact that sits at the back of the record and does not announce itself. Now let it sit with you for a moment in whatever quiet you have around you. The work of assembling the record, the decisions, the arguments, the music choices, the failed attempts, and the things that almost made it, and the things that were included at the last minute, is documented in the book called Murmurs of Earth, published in 1978. Sagan, Druyan, Drake, Ferris, Lomberg, and Linda Salzman Sagan all contributed to it. It is the record's companion, its annotation, its behind-the-scenes account. Everything that didn't fit into a groove or an encoded image lives there, the reasoning, the regrets, the context. The book explains nearly every choice. Why the cavatina near the end? Why Blind Willie Johnson? Why the calibration circle comes first? Why the hydrogen atom defines the master clock? Why the Navajo night chant and not some other Navajo piece. All of it reasoned through by the people who did the reasoning and then written down. Murmurs of Earth is out of print now, but it exists. The reasoning exists. The record itself exists. The record has been out there in the dark for more than 47 years. Voyager 1 entered interstellar space in 2013. That is when NASA announced it, confirmed by the changes in the particle environment detected by the craft's instruments. The boundary the spacecraft had crossed was the heliopause, the edge of the heliosphere, the region where the solar wind is no longer strong enough to push back against the interstellar medium. Beyond that boundary, the sun's direct influence ends. What's there instead is the space between the stars, a different kind of dark than the dark within our solar system, older, quieter, the raw fabric of the galaxy. The record on Voyager 1 is there now. It is in interstellar space, traveling at roughly 17 kilometers per second, which sounds fast and is fast for any human frame of reference, and is still cosmically, almost amusingly, slow. At that speed, the distances between stars are measured in tens of thousands of years. Voyager 2 crossed the heliopause in 2018, 5 years after its twin, following a different trajectory, taking a different path through the outer planets, and then out. Both records have now left the sun's bubble of influence. Both copies of Bach's Brandenburg Concerto and Valia Balkanska's voice and Anne Druyan's brainwaves and the Navajo night chant are in interstellar space. In about 40,000 years, Voyager 1 will pass within roughly 1.6 light-years of a star called Gliese 445, also catalogued as AC plus 79388. It will not impact the star, it will not orbit it. It will pass in the vicinity, in cosmic terms, and then continue. Neither record is aimed at anything. They are not directed toward a specific destination. They will simply drift and for billions of years, possibly, long past the time when the sun has changed into something unrecognizable, long past the time when the Earth itself has been altered beyond anything we could describe. The records will keep going. The gold surface will remain readable in principle for roughly 1 billion years. Long after everything that made them, the buildings, the institutions, the languages, the species, has transformed into something else, 2 gold-plated copper discs will be moving through the dark, carrying the Brandenburg Concerto and Johnny B. Good and the sound of a kiss, and a mother soothing a baby and the brain waves of a woman in love. There is a way of thinking about this that becomes almost too large to hold. 1 billion years. The Earth is about 4.5 billion years old. 1 billion years ago, there were no animals on this planet. Single-celled life existed and some multicellular experiments, but nothing that could hear music. And in 1 billion more years, the records will still be there, still carrying all of this, moving through a galaxy that will have shifted and drifted in ways we cannot fully model. The records will outlast the memory of having made them. They will outlast the planet. They will outlast, almost certainly, the sun. What the committee made was not in the end a message to aliens, though that is how it has always been described. What they made was a time capsule thrown so far into time that time capsule barely covers it. They made something for after us, after Earth, after the sun. An artifact from the moment when one small species on one small planet briefly turned its face toward the sky and said, "Here is what we are, here is what we sound like, here is what we love, here is a sample of our brains and our music and our weather and our languages, ancient and new. Here is the cry of a newborn and the launch of a rocket and 3 Bach pieces and a woman thinking about love and the song of the humpback whale. Here, you are lying somewhere tonight, on a bed or a couch, or in a chair in a particular room, in a particular city or town or village that is somewhere on this planet. The same planet whose volcanoes and surf and birdsong are encoded in the groove of a disk now moving through interstellar space. You are part of what that record was trying to describe, not abstractly, literally. The sounds of Earth include sounds from wherever you are. The greetings in 55 languages include some ancestor of whatever language you think in. The EEG encoded in the gold is the brainwaves of a woman in love, but love is not foreign to you. The heartbeat in the sounds montage is a human heartbeat, and your heart is beating right now steadily, doing what heartbeats do. The atoms in your body were forged in stars. You know this probably. But it bears sitting with the carbon in your cells, the oxygen you're breathing slowly right now, the iron in your blood. These are stellar material. The same forces that made the gold on the record made the elements in you. The same hydrogen whose hyperfine transition ticks on the cover diagram of the golden record is the hydrogen that fuses in the core of the sun that warms this planet that you are sleeping on tonight. You are not separate from any of this. You are an expression of it. The record went out to describe something, and part of what it described is you. And out there, past the heliopause, past the 40,000-year drift, past Gliese 445, past anything we could name or reach or imagine reaching, two small things are moving, gold-plated, patient, carrying the cavatina and the shakuhachi and the calibration circle and the pulsar map and the uranium clock and the voice of a 6-year-old saying hello and the voice of a Bulgarian woman with something piercing in her and the sound of rain. They are going. They have been going. They will go. Wherever you are tonight, whatever time the clock says in your corner of the world, the record is out there. The Bach is out there. The whale song is out there. And Druyan's hour of thought is out there. It has been there since 1977, and it will be there long after there is no one left to know what 1977 meant. That is a gentle thing to carry into sleep if you let it be. Not frightening, gentle. The universe is very large and very old, and somewhere in the middle of it, one small species put its music on a disc and let it go. And the disc is still going. You don't need to solve anything tonight. You don't need to understand the hydrogen hyperfine transition or remember the exact half-life of uranium-238 or keep the names of the 55 languages in your mind. The record will remember all of it. The record has it. You can let it go. If you're still awake, and it's all right if you are, and it's all right if you're not, this is the part where we settle. The music has played. The brainwaves are encoded. The two spacecraft are moving. The cavatina is near the edge of the solar system and a little beyond it, and it is patient, and it has time, more time than we can hold. If you've been here for this whole journey, the gold and the copper, the phonograph cartridge bundled beside the disc, the hydrogen atom drawn in its two states, the 14 pulsars like lighthouses, the calibration circle that proves the picture is right, the uranium glued to the cover like a tiny clock, the Akkadian and the Sumerian, the 6-year-old Nick Sagan, the whale song threaded among the human voices, the Saturn V climbing out of the sounds montage, the 3 Bach pieces, the Bulgarian piercing voice, the blind Willie Johnson slide guitar, the meditated hour of Druyan. If you've carried any of this tonight, then you know something real now, not just that the record exists, something about what is actually on it and what it cost to decide, and what it means that one of the things encoded in it is a woman's brain during the first days of love. That's a real thing. That happened. It is happening still, in its way, out there, in the dark. If this slow journey helped you find some rest tonight, or gave you something quiet to drift on, it would mean a lot if you left a like, or subscribed to Night Watch Observer. Small creators like me rely on that kind of support to keep making these long, slow things. And if you want to leave a comment, wherever you are, whatever time it is in your corner of the night, I'd love to know. That's the question I keep asking, and I keep meaning it. Where are you listening from? What does the dark look like there? Thank you for being here. Thank you for staying, or for drifting off somewhere in the middle of it, which is exactly what this was made for. The record is going, the gold is holding, the music is encoded, and it is patient, and it will last. The night watch has the dark covered. You can let go now.